Let's solve finding the equation of a straight line. Consider this one. The gradient m is equivalent to the ratio of the vertical distance and the horizontal distance. Given the 2 points on the straight line, A with the coordinates 0, C, and B with the coordinates xy, we can find the horizontal distance as x minus 0 and vertical distance as y minus c. And substitute to the formula of the gradient, we have m equals y minus c all over x minus 0. Simplifying this, we have m multiplied to x minus 0 is equivalent to y minus c. X minus 0 is x times m, so that's mx equals y minus c, and isolating y, it will become mx plus c. So this is the formula for us to find the equation of a straight line. So for a straight line passing through the point 0, c, and with gradient m, the equation is y equals mx plus c. Let's have the first example. Find the equation of a straight line passing through each of the following pairs of points: a, negative 2, 1, and b, 5, 3. The first step is to find m. Since we have 2 points, we can label this point A as x sub 1, y sub 1, and the point B as x sub 2, y sub 2, and substitute to the formula m equals y sub 2 minus y sub 1 all over x sub 2 minus x sub 1. And the value of m is 2 over 7. Second step is to find the value of c, or the y-intercept. Choose any point, it could be A or B, so let's choose A, and use this as the values of x and y, substituting to the formula y equals mx plus c. And the value of c is 11 over 7. So we have the value of the gradient and the value of the y-intercept. We can now substitute it to our formula y equals mx plus c. So the equation is y equals 2 over 7x plus 11 over 7. Let's have the second example. Find the equation of the straight line passing through the points C and B. So the first step is to find the value of the gradient. So C is the x sub 1, y sub 1, and B as the x sub 2, y sub 2. And substitute to the formula y sub 2 minus y sub 1 all over x sub 2 minus x sub 1. And the value of m is 0. So since the m is 0, it means it is a horizontal line or a line parallel to x-axis. Second step is to find the value of c. We can choose from any point C and B. Let's say I choose point C as the values for x and y in the formula y equals mx plus c. And the value of c is 4. So we now have the value of the gradient and the value of the y-intercept c. So the third step is to substitute. So the equation is y equals 0x plus 4, simplify, y equals 4. Now let's have the third example. The line passes through the origin and has a gradient of negative 1/2. So first step is to find the gradient, and the gradient here is negative 1/2. Second step is to find the value of c. Since the line passes through the origin, it means the point is 0, 0. So which means it crosses the y-axis at 0. So the y-intercept is 0. The m value and the c value are complete, so we can now have the third step to substitute it to our formula. Y equals mx plus c. So the equation is y equals negative 1/2 x plus c. To simplify, y equals negative 1/2 x. The fourth example. The line crosses the y-axis at 3 and has a gradient of negative 5. Again, first step is to find m. And in here, m is equal to negative 5. Second is to find the value of the y-intercept c. So the line crosses the y-axis at 3, it means the point is 0, 3, and since it crosses the y-axis at 3, then the value of the y-intercept is 3. So we have now the value of gradient and the value of the y-intercept. So for the third, we have to substitute it to our formula y equals mx plus c. So the equation is y equals negative 5x plus 3. For the fifth example, the line has an x-intercept of 1 and has a gradient of 1 over 4. So first step, find m. And in this problem, the value of m is 1 over 4. Second step is to find the value of the y-intercept c. From this given, the x-intercept is 1. It means we can create a point using this condition, and the point is 1, 0. So we can use 1, 0 as the value of x and y and substitute it to our formula. So c is negative 1 over 4. We have the value of the gradient and the value of the y-intercept c, so we can now substitute it to our formula y equals mx plus c. So the equation is y equals 1 over 4x minus 1 over 4. For the sixth example, the line passes through -1, 2 and parallel to the line y equals 4x minus 5. The first step is again to find the value of the gradient. Since the line that is unknown is parallel to the given line y equals 4x minus 5, whatever is the gradient of this line is also the gradient of the line that we're looking for. So here, the gradient of the line y equals 4x minus 5 is 4. Since the gradient of the first line is 4, so the gradient of the line that we're looking for is also 4. So we now have the value of the gradient. Second step is to find the value of c, or the y-intercept. Using the point -1, 2, this will be the values of x and y, and substitute to the formula y equals mx plus c. So the value of c is 6. Third step is to substitute m and c to the formula y equals mx plus c. So the equation is y equals 4x plus 6. For the last example, the line passes through 1, 1 and perpendicular to the line y equals -2x plus 1. First step is to find the value of the gradient. Since this is perpendicular to the line y equals -2x plus 1, we have to find the gradient of this line. And the gradient of this line is -2. Since perpendicular, we need the negative reciprocal of -2, which is +1/2, as the gradient of the line that we're looking for. So we now have the value of the gradient. Second step is to find the value of the y-intercept c. We need to use the point 1, 1 as values of x and y and substitute to the formula y equals mx plus c. So the value of c is 1/2. Third, since we now have the value of m and the value of the y-intercept c, substitute the values to our formula y equals mx plus c. So the equation is y equals 1/2x plus 1/2.